Hi everyone, my name is Benjamin, and in today's video I will introduce you to raw shreds forwarding, the earliest possible on-chain signal. So we are going to cover what shreds are in the Solana ecosystem, what raw shred forwarding means and how to enable it, and eventually we will build a simple TypeScript tool to verify if shreds arrive over UDP on our SVS VPS. And on top of that, all the code will be available for download via our GitHub repository. For more information, you can always check out our official documentation or join our great Discord community. Both links will be in the description, and with that said, let's get started. Alright, so before we're going to build our tool and enable raw shred forwarding, let's discuss what shreds are and what we mean with forwarding raw shreds. So, shreds are the smallest units of data that will make up a block. So, in other words, they are essentially fragments or fractions of a block, and they are the smallest units of data that is sent between validators. Now, Solana is a high-performance blockchain designed for speed and high throughput, and in order to achieve this, it cannot just send these whole blocks over the network, and therefore the current leader validator will split up these blocks into smaller pieces or packets, and these packets are also called shreds. So when you create and sign a transaction via, for example, a Phantom wallet or a dApp, you send that signed transaction to a public or private RPC endpoint, which serves as an intermediate between you and the validator nodes, because most of the time RPC nodes that we interact with, they are non-voting. Now, once the RPC nodes receive it, it will forward that raw transaction as UDP packets and more recently as quick streams to the validators, and then eventually to the current leader validator's TPU port. Now, once the current leader validator receives your transaction, it will execute that transaction based on the priority it was given using fees and compute unit pricing. It will then include that transaction into an entry, which is a batch of transactions, shreds that entry, and broadcast these shreds via Turbine. And Turbine is essentially Solana's block propagation protocol. In other words, it is the system that is responsible for quickly and efficiently spreading newly produced blocks in the form of shreds, of course, from the current leader validator to all other validators across the network. Now, an important detail is that the current leader validator creates two main types of shreds, and the first type is data shreds, and they actually contain executed transaction data. They're fragments that contain your transactions and everything that happened within that block, and they're typically around 1200 bytes big. Now, on the other hand, we have code shreds, and they do not contain any transaction data. Instead, they are error correcting pieces using Reed Salomon as a error correction technique that generates parity data. And you can think of it as backup shreds or backup data that lets any receiver of these shreds reconstruct missing data shreds if some of these packets are lost or delayed on the network. Alright, so to recap, we send our transaction to our RPC node, and that RPC node forwards these transactions as quick streams or the legacy UDP packets directly to the current leader TPU port. The current leader receives these transactions, processes the transactions, executes them, and bundles them into entries. And after the entries have been produced, they are being serialized and broken down into fixed size data shreds. Then there is a Reed Solomon encoder that will make sure code shreds are enabled and that a complete erasure set is created. The current leader validator then broadcasts these shreds via Turbine to all other validators on the network, and other validators receive these shreds, they reassemble them as a block, they verify, and they vote. Alright, so now that we know what shreds are, what do we mean with raw shred forwarding? So we know that these shreds are being broadcasted from the current leader via Turbine, and our cluster of shared RPC nodes, validator peers, and some Jito block engine locations actively collect shreds early and then relay them directly to your VPS over UDP. And our tool that we're going to build binds a UDP socket to a certain port that we are going to receive these shreds on, and then they are available in our codebase. Alright, so with that said, I will now show you how you can enable raw shred forwarding and that they can be forwarded to your VPS. Alright, so as a reminder, you can always find more information about raw shreds forwarding via our official documentation at docs.solanavibestation.com, and there you'll find a quick overview of the shred services that are available both for Atlanta and Amsterdam, some use cases of course, and also how you can purchase any of our raw shreds forwarding services. Now that you can do or by going to our Discord server, and then under purchased services, you can subscribe to raw shreds for our Amsterdam location. And as you can see, once your subscription is active, you can manage IP forwarding. And the great thing is that we offer really flexible duration options to get you started. Now, besides that, for our Atlanta infrastructure, you can enable raw shreds forwarding as a add-on when buying a VPS, or it can be added later on for our existing VPS customers. And you can do that by going to cloud.solanavibestation.com and then under services, cloud services, then you can click on your VPS that is listed there. Now, once you click on that, you will see a nice overview of your server details. And under billing, you can request raw shreds to be added to your VPS as a add-on. Now, once this is enabled, you also need to make sure that you configure a inbound firewall rule to allow UDP packets on port 20,000, and that you can do by clicking on Add New Rule. Now, this is really important, and if it's not set properly, you will not be able to receive these packets. Now, once you have enabled raw shreds forwarding and you have properly configured your firewall, you are ready to receive these packets, and that's exactly what we are going to do now by building a really simple TypeScript tool and verify if we can receive these forwarded raw shreds. So with that said, let's check out our code. Alright, so this is our code base for today, and it's a really simple tool that we will use to verify if these shreds arrive on our VPS. So the file that we're looking at is server.ts, and what we are going to do here is specify a port which is 20,000 because this is the port that the packets will be sent to. And then we have the host, and we can just specify this as we are going to run this on our SVS VPS. And we also specify some expected shred sizes, which we can later use to do some basic validation once these shreds come in. Then we are going to create a server object, and for that we are using ddram, and ddram is just a Node.js module that comes out of the box that we can use to set up these UDP socket connections. And then we can also specify the port where we want to listen for. Next, as always, when we are using streamed connections, we are going to set up these listeners, and once we have that server object, we can create a listener for the messages that come in once an error occurred, and then we're also going to output that error and close our streamed connection. And also, once we are listening, we are going to output that in our console, as you can see here. So we're going to output that we are now listening for shreds on this address on that port, and also we are going to add a tip, because once we start that stream, all these shreds will come in, and if they don't, then the user will see this message on top of the terminal, and it will have a tip to make sure that the firewall is configured. Now, next, we're also going to bind that port to the host, as you can see here, and that will also start our stream, and we have some logic to make sure that we can handle a graceful shutdown once we press the Ctrl+C in our terminal. Alright, so the most important listener, of course, is the message listener. So once a message comes through in the form of a buffer, we are going to have this logic here to handle that, and we're also going to receive some basic information from the remote host sending us these shreds. Then we were going to set a timestamp and also a size, and the size we just specify by looking at the buffer and at the length from the buffer. And then we can use these expected shred sizes to see if that buffer size falls within the expected sizes that we specified here on top. And if it falls outside that range, we are going to skip that shred. We're not going to handle that because we are expecting a certain size of shreds to be delivered. Next, we are going to extract some metadata from the shreds that we receive, and we can do that by looking at the buffer that we receive here and then specifying a certain offset. And these offsets, they are all documented here within the official Solana Foundation documentation under the shred documentation. And then we can extract things like the slot, the shred index, the shred version, and also the high and the low bits, which we will use to determine if the shred type is data or code. And remember, we discussed this earlier. We are going to receive these code shreds and these data shreds. And also the out type can be legacy or Merkle. And I believe most of the shreds that we are going to receive will be Merkle. And that means that they are signed as an entire FAQ set. and not as each packet alone. However, if you want to know more about that, you can also check out the official documentation here. Now we are just specifying these two types that we can use to output here in our console to do some basic validation of the shreds that we are receiving. Now further, based on the high and the low bits that we extracted here, we can specify if we are looking at a code or a data shred. As you can see here, we're going to look at these high bits and these low bits, and if they fall within a certain range, we can assign a shred type and a auth type, and that's what we do here. And then further down, what we are going to do is just output all that information that we extracted here, that metadata and the type of the shred. We're going to output that in our console to see if these shreds are actually being received on our VPS. So we're going to output the timestamp, the type of shred that was received, where it was sent from, and the port, of course, and also the slot, the shred index, the shred version, and all that information that was extracted. And we're also going to output the first 32 bytes that you can see here that we are extracting from that message. So we're going to take the first 32 bytes from the buffer that was sent to us, just as some additional information that we can output in our console. Now, the next thing that we are going to do is send this small tool to our VPS, and then we can run it there because that's where we will receive these UDP shreds. So what we can do is open a new terminal. And as you can see here, I already have two terminals open. The first one is just a SSH connection that I established with my VPS. As you can see, this is the temp directory, and I have a other shell here. And what I will do here is just using SCP to send that code base to my VPS. And SCP is just a tool that will copy all these files over SSH to my VPS. And since this is a really small tool, this is now the best way to do that. However, you can always use tools like Git, for example, where you can send your changes to Git and then pull them on your VPS. However, for the purpose of this video, to keep it light and simple, I'm using SCP to send these files to my VPS. And as you can see here, I specify the directory that we have that tool in and also the location, and we're going to store that in the temp file. So if I click enter now, this will ask for my key, of course, as I'm using SSH. And once I provide that key, it will start sending and copying these files to our VPS. And as you can see, it's not that many files at all. And if I go back to my VPS, and if I list now the contents here, you will see that we have that folder there, raw shred forwarding. And that's what we just copied to our VPS. So if we go to that folder, cd raw shreds forwarding, we can clear the terminal. And the first thing that we can do here is use pnpm or npm, whichever you like the most, to build that tool. So we're going to first install everything, because also this tool has certain dependencies. It's not that much. It only uses Node and TypeScript. And then we can also build that tool. And that's what we are doing now. So we're going to build the tool, and eventually we're also going to start the tool. And then you will see that these shreds are being delivered to our VPS because they're all coming in. So if we stop that using Ctrl+C, you can scroll through all these shreds that you have received. And this is exactly what we outputted in our console that we did earlier in our code base. As you can see, we receive code shreds, Merkle it says here, the size that was expected, and also where the shred was sent from, the slot, the shred index, the shred version, and all that information as the first 32 bytes that we want to output in our console is here. Now, as you can see, we are receiving both these data shreds and also these code shreds, I believe. As you can see here, code shred, data shred. So we see that the basic logic is working, and that the tool to verify if these shreds arrive on our VPS is also doing its job. Now, further down the line, you will have to look into the shreds that come in, and you will have to build the logic to reassemble these shreds and actually get out some valuable data. And that is something that we are going to do for sure in the next videos. This was just an introduction into the raw shreds, how you can enable it on your VPS, what they are, what it means, raw shred forwarding, and also once it is enabled, how you can verify if they are being received on your VPS. So the code will be available, so you can always get it via our GitHub repository. The link will be in the description. And with that said, I hope you now understand raw shreds a bit better now, and that it was interesting, and I'll see you in the next one.